in this fight you see the glass battery and nanostructure films, and some fight this microphotos by triazines investigated by microhardness meters. You see the formation of the big particles in top corner, and you see the image of the body was CO2 plus triazines. And this triazines interesting because sorry, this triazine interesting because they have triazine groups who have photoactivity, photosensibility, and you see the figure some extinction coefficient and refractions index of triazines. It's we have obtained it by spectra of voltaicity, and now we work from investigated with what the substitute of triazines have defined by both in this graphics some of this peaks from this fight, and you see we have publication of some of the results. And next slide. And I can tell you generally of heterocycle compounds and the market of heterocycle compounds in you see in the slides what the market of and what's the popular heterocycle compounds in USA market and the price who buys this heterocycle compounds and activity. Some of them and this data was shown FDA database, and I can tell you more than 60% unique small molecules drugs have contained by nitrogen heterocycles. It's interesting because the pharmaceutic like and the nitrogen based heterocycle very popular in these aspects, and the synthesized on this. You show the statistics and some of them you see it's heterocycle structure with most market drugs. This most popular of USA market drugs, the database of FDA USA. And this slides you see some graphics from FDA. It's anti-tumor drugs during the calendar from some year. You see in this graphics, and this diagrams you see what the percent of some of heterocycle compounds. You see the nitrogen based compounds have 33%, and the new drugs from FDA database. And according to statistics, more than 85% all the biologics active contained by heterocycles. It's interesting because the heterocycle provide the use tools for modification of soluble lipophilic polarity and hydrogen bond capacity biologics active against results the optimized ADME tox properties of drugs or drugs candidates. And if you see the slides, You see the drugs who nitrogen-based drugs very popular from chemotherapeutic drugs, and it's generally more the all class of heterocycle compounds. And the start, I can tell you, imidazole. Imidazole heterocycles have a 9th position in top 25s of nitrogen heterocycle, the database by USA FDA approved drugs, and this structure have inhibitors by tubulins and the G2M abragotes and other, and some of them you see have polycycling structure. It's verbustine. You see the big molecules, and some of them imidazole compounds have indoles, and imidazole are very popular because they inventions more than 20th century year or more, and this interesting synthesis. I show you synthesis our partners in Yenamin. It's city Kiev. It's capital from Ukraine. These compounds you see have 3 or 4 heterocycles: pyrimidine, piperidine, and triazoles. The synthesis have good yield from each studies, and the this compounds you see have the screening of and okay, next slide. Because some of the structure interesting because they have polyvalent structure from heterocycles, and these compounds have many biologics activity. After this class is pyrimidines derivatives. You see the statistics by FDA. It's 2017-2018 year. You see the pyrimidine compounds and the biologics activity. The database FDA. They have many pharmacological activity. Some of them anti-cancer, antiviral, anti-protozoal, anti-fungicide, and antibacterial activity. And they vary like from anti-cancer therapy. You see them in these slides. Okay. The synthesis of pyrimidines compounds, it's synthesized by our partner in Yenamin. They are preparated by other pyrimidines acids. You see some of them in the slides, but these acids have poor yield, and this reactions is very harsh conditions or big. You see the poor yield. This reactions on our the studies. The starting by nucleophile substitution in chlor from oxazole, and after the synthesized from acids on this pyrimidines. These compounds have some antimicrobial activity, and as synthesis, these compounds have good blocks from organics synthesis, and the scaffold of the structure have building blocks from synthesis other compounds, and but some of them have, you see in this structure, you have diversion by agrochemistry and discovery from fungicidic activity. Okay, next synthesis. It's heteroaromatic scaffold because interesting, the structure have oxazole moiety. Oxazole compounds have showing the good anti-cancer activity, but they have higher toxicity, and the family of some of them oxygen hetero or nitrogen heterocycle compounds have good in tumor anti-tumor activity, and synthesis was found by our partner in Kiev. They have good yield from our each studies reactions, and they boxed compounds, and after substitution in NH groups from, you see in this articles, okay. Another class of heterocycle compounds is pyridines. Pyridines was most common heterocycle fragments present of FDA approved drugs. More than 50 or percent of heterocycle fragments in FDA, it's pyridines. They have structure of pyridines, and some of the synthesis you see in this slides, and this is substituted by atom of brom in different different amines, and interesting structure you see this in point 9. They have anti-tumor activity, and they have effective against hepatocarcinoma cells lines, hep G2, and they inhibit him from 90.20 millimeters, and they have ability to regulate it AMPK photophosphorylated. And the next slide, it's our team's photo. It's my scientific research. My supervisor, our teams work from synthesis antimicrobial and antibactericidal compounds who have nitrogen contains derivatives 19-anthrachinone, and the reactions was diazotated, nucleophile substitution, and other coupling. We have synthesized many pharmacophore functional groups from scaffold of anthrachinone moiety. Okay, thank you for attention, and you can ask me your questions. Okay.
Respected participants, please ask your doubts. Chat box only. Put your questions in chat box. Hello, sir.
Yeah. You can.
Can you share the PPT as we cannot write down? Oh.
Okay.
How can we overcome side product?
No.
Murugan asks, how can we overcome formation of side products.
Formation sign drugs. You can repeat the questions.
Okay. How can we overcome formation of side products?
Formation, some pharmaceutical drugs.
Yeah.
It's many many reactions we can choose: cyclizated, coupling, condensation. Now it's popular from microsynthesis or synthesis from microwire. It's they have good yield and the time of reactions very slow, and these reactions did not have high pressure. It's future from organic chemistry. I think the microwave synthesis and synthesis from micro structure. Okay.
Any questions? Please put your chat box. Did you observe any diazo coupling with aromatic ring rather than acid formation?
In this slide? No.
Did you observe any diazo coupling with aromatic ring rather than acid formation?
No, we think about this, writing some articles, review from another coupling of all reactions, or aromatics, or anthracene, or other, but no, we just now we did not observe and review of writing from, did not writing some articles.
Next.
It's very hard because reactions more and time is it's very slow.
Okay.
Maybe future.
Okay. So next one question is that how can we condense any compound in first or second position of anthraquinone IT as you did in your research?
How we can condensate it from
first and second position of anthraquinone mighty?
Cyclizated or condensated, the structure. I can tell you this now. It's popular reactions. It's discussed in scientific how we can condensate it or cyclizate it some anthraquinone structure, and the Germans organic chemistry, Eunice Baki and Kirsten Müller, synthesis many compounds, and I know the Indian science Patels, who synthesized of some compounds from brominic acids. And just now we work from this condensation synthesis these compounds.
And next question: what is the mechanism action of anthraquinone derivatives and anti-inflammation?
I repeat your questions, please.
Oh, okay. What is the mechanism action of anthraquinone derivatives and anti-inflammation?
Okay. This structure have have alkylated some molecule of DNA, if this compounds is obtained in this diazo of this triazines, in have alkylated some molecule of DNA, and this biologic activity of this compounds was ability from this triazines or diazome salt can by alkylated of some molecules of DNA, and this structure was not toxicity from mouse, rats, and proposed and human too. I think this compound is not toxicity. What's the next questions?
Next question. The reaction you use copper and iron. What is the role of both Lewis catalysts in this reaction?
The reactions.
You can use in both copper and iron.
What copper iron
in this reaction? What's the role of this Lewis catalyst?
It's different amines we chose from these reactions. Some of them it's amino acids, aryl amino, dialkyl amines, different heterocycle compounds, pyridines, pyrimidines, or folines, or other amines. Ions we chose from diazo ions in chlor, sulfur, phosphorate, or cuprum chloride. Stop presentation now. Okay.
Next question. You have used anthracene only. What about activity of naphthalene? Would you check it?
Repeat your questions, please.
You have used anthracene only. What about the activity of naphthalene? Would you check it?
Naphthalene. No, naphthalene, it's very hard in these reactions. They gives azo compounds, not triazines. They have azo compounds, and because they have other compounds, this naphthalene compounds was not interesting in our teams. But some science I think work from naphthalene compounds, but this is diers. But all this naphthalene compounds is coping, not triazines, and this this diers always they have diers properties.
Okay, so fine. Next question. Can you show the anti-cancer or anti-ulcer action of any of your product?
Anti-cancer
or anti-ulcer actions?
Okay. Yes, these compounds have anti-cancer properties. The screening was experimental screening by USA NC protocols in Massachusetts, some Institute of Cancer of Brazil, USA, but not all, almost not the compound. Some but some of the compounds have anti-cancer properties. Some of them. They have compounds who have high hydrogen structure. You see in the structure in the slides. have good anti-cancer properties. It's hydrazones, anthraquinone hydrazones have good anti-cancer properties, and some of triazines, some of triazines.
Next question. How can I compare the first hyperpolarizability values derivatives of the same compound? For example, anthraquinone derivatives.
Can you repeat start of your questions?
Yeah, I need a repeat.
Yeah, okay. Can you repeat?
Yeah. How can I compare the first hyperpolarizability values of different derivatives of same compound? For example, anthraquinone derivatives.
Okay.
How can I compare? Yeah. How can I compare hyperpolarizability?
How we can? This compounds was they have natural structure, and according to the chemistry, they incorporated into polymers and oligomers synthesis and use from novel heterocycle compounds. If I write you of questions, I have some problems from sounds or internet.
Okay, fine. Sir. Thank you. Now we have concluded our session. Dear ladies and gentlemen, good evening, everyone. First of all, I thank to all the participants for your kind attention and patience. Thank you. My heartfelt thanks to our principal because of her continuous and valuable support to make the webinar today. And I thank our convener, my friend, Mr. Nepal Raj. On behalf of Annai group of my institutions, I take immense pleasure to thank our chief guest, Dr. Shepanik, head researcher, Department of Environmental Chemistry and Chemical Education from Ukraine. Thank you very much, sir. Very nice presentation.
Okay, great. See you.
Yeah. Thank you, one and all. Thank you, sir.
Thank you. All the presence on my lecture. It's not nice. Pleasure for present you work from me and my teams.
Thank you, sir.
And I in future we have some cooperation with our university, scientific cooperation.
Sure, welcome. Thank you, sir. Thank you so much.
Thank you.